I would like to welcome everyone to the product release webinar for the iC7mini Blue Box and the newest version of SmartCode. My name is Roger Smith. I am responsible for technical marketing at Tasking and will be the speaker for today's webinar. As a recognized leader in high quality, functionally safe, and security compliant embedded software development tools, Tasking allows you to create best-in-class code size and performance with compilers, debuggers, and RTOS support for industry-leading microprocessors and microcontrollers. In addition to the VX toolset for ARM, Tasking offers toolsets for the RX TC2, TC3, and TC4 families from Infineon. The Tri-Core and ARM toolchains are ASPICE Level 2 compliant, conform to the ISO 21434 cybersecurity standard, and are TÜV certified according to ISO 26262 up to ASIL D. With the acquisition of iSystem, Tasking now offers a full system solution as the Blue Box establishes the debug and trace connection to the target processor, and WinIDEA provides a versatile and powerful embedded software IDE. The Tasking safety and security ecosystem includes the Tri-Core Inspector, which provides embedded system developers a method for identifying if any SIL toolset related issues are in their compiled output code. The Safety Checker Static Analysis tool helps to ensure freedom from interference is maintained in ECUs with software components having different ASIL levels. The qualified C libraries for Tri-Core were developed as a safety element out of context using state-of-the-art algorithms, resulting in reduced memory footprints, reduced execution times, high numerical accuracy, and about 200 functions qualified for ASIL D use. The Tasking Performance Tools Embedded Profiler and Multi-Core Performance Tool provide fast and efficient access to flow tracing information to resolve stalls, cache misses, and optimize the core load in your multi-core system. Finally, Tasking offers RX-optimized LAPACK performance libraries to provide accurate solutions for your complex mathematical operations, and the Tasking Pin Mapper tool provides hardware configuration and RX port mapping for your PCB development. Today, we will be focusing on SmartCode, which is located here in the overall design process, and the Blue Box debugger. This webinar will be recorded and available on our website at the link shown below. In case any questions arise during the webinar, we invite you to use the Q&A function on your Zoom console. All questions will be answered at the completion of the webinar. I'd like to now introduce myself. My name is Roger Smith. I'm an electrical engineer with over 25 years of industry experience designing, implementing, and debugging automotive electronics. In my previous role, I spent 12 years as an application engineer supporting braking, electrical power steering, passive safety, and ADAS applications for a global leader in automotive semiconductors. As the technical marketing manager for Tasking, I support a wide range of multi-core embedded software development tools. Before we begin, I would like to wish our attendees a good morning, good afternoon, or good evening, depending on what part of the world you're tuning in from. Automotive electronics has evolved into a network of interconnected electronic control units performing advanced algorithms relying on multi-core microcontrollers, data sharing, multi-threaded operations, and high-speed communication. These advancements have led to the most basic functions having an automotive safety integrity level rating. Shown in this diagram are applications available on the vehicle, as well as their highest rated safety case violation. Our two young engineers have been tasked with designing a TC4X safety application. This can be a daunting task and analogous to climbing to the peak of Mount Everest. As our two young engineers begin their arduous journey to the peak, they will encounter several challenges along the way. The first step of the process involves selecting the appropriate microcontroller, like the Infineon TC4X. This device has a scalable family approach, integrated FPU, redundant peripherals, and a platform safety concept, which make it ideal for automotive safety applications. The next step is to identify a tool set which supports all the cores integrated into the device. For example, the TC4X includes the Tri-Core 1.8 architecture, a Synopsys parallel processing unit, the Bosch generic timer module, an 8-bit standby control regulator, as well as others. The developer has the option of purchasing individual tool sets for each one of these different architectures, or a heterogeneous tool set which provides compiler support for all cores. Automotive safety applications require ISO 26262 and ISO 21434 compliance for the hardware, software, and software tool set. In addition, a flexible and high-performing hardware debugger will be necessary and needed, as well as a versatile and easy-to-use debug IDE with trace and signal monitor and injection capability. During this webinar, Tasking will offer two solutions to help our two engineers during their development of a functionally safe, security-compliant automotive safety system using the Infineon TC4X. We will be introducing SmartCode, which is our compiler toolset for the TC4X, as well as the new iC7mini Blue Box hardware debugger. So what is the iC7mini? The iC7mini is the 7th generation of the Blue Box hardware debugger. So why do we need a next generation? The existing iC5000 and iC5700 are mature solutions in need of an update. These solutions will still be available, but Tasking recommends the new iC7 family of Blue Box hardware debuggers for an optimal debug and trace solution as you move forward. Functionality needed to be extended in order to support new interfaces and offer new debug trace solutions. Some of the current supported architectures include the Infineon Tri-Core, NXP ST Power Architecture, Renesas RH850, ARM Cortex, RISC-V, as well as others. We invite you to come to the link here on our website in order for you to see the different supported chips with our debuggers. High-performance automotive applications using state-of-the-art multi-core microcontroller architectures require a high-performance hardware debugger and flexible yet powerful software IDE. And now Tasking also offers a cost-effective, complete system solution for our customers, which cover the whole development process from the beginning: build tools, compiler, assembler, linker, locator, as well as connecting to the hardware target, hardware debugger, and software debug IDE. So let's look at some of the improved performance that we achieve now with the iC7mini. So our improved performance allows faster debugger response time, which provides a much smoother GUI experience for our users. The improved ECU performance maintains debug signal integrity when operating in noisy environments or with pre-production intent hardware. A lot of times software is developed on mule level or A-level hardware, which does not have all of the EMC type protections integrated. And so these platforms can be a little noisy. And so the improved ECU performance of the hardware debugger helps to maintain this debug signal integrity. The improved performance also allows us to operate now in a continuous integration environment. Tests to date within a CI environment have executed twice as fast as our previous debug solutions. The improved performance also allows us to work with customers who have remote farms. Global teams now have global sites set up where software developers can sit in one region and a hardware development debug stack can sit in another region of the world. The smaller form factor of the iC7mini is ideal for integrating into this test rack type system. So if we look here at the feature table of the iC7, so the iC7 will be rolled out as a family. The three members of the family will be the iC7 Mini, the iC7 Pro, and the iC7 Max. you can see the iC7mini is available today for order and contains a USB Ethernet interface, allows debug at 120 megahertz, and the distance from the debugger to the target can be 30 centimeters. You'll see there's also some on-chip trace capability if you're using, for example, an Infineon emulation device. When we look at some of the like the iC7 Pro and the iC7 Max, they will be available mid-2024. You'll see they also add on the capability of SoC trace, sample trace, high-speed trace, as well as multi-SoC debug and trace, and the ability to observe signals outside of the target device, including CAN, LIN, SPI, analog, and digital I/O. The WinIDEA version that will be necessary for working with the iC7 family minimally must be 9.21.213. And if you look on the website right now, version 217, so 9.21.217 is available. If we look at a high-level block diagram of our system, you can see here the iC7mini hardware debugger connects to the adapter, which is target dependent via a ribbon cable. In the future, there will be an optional converter here for some additional added functionality. And you can see here, this is a TC4X evaluation board, which we're using for this example. If we look at our licensing model, we will offer a term or time-based license. This will be a 1-year typical. You can see here in parentheses that it is negotiable. So if you'd like a 6-month or a 2-year, for example, please reach out to our sales team and they will be able to assist you with setting up your license for this time period. Maintenance is included with this license, and with the time-based license, once the expiration or the time-based date expires, you will no longer be able to use your software. The other method or the other model which will be available is a permanent license. Now, with a permanent license, you can use this, permanently, as is indicated in the name. However, you will lose the ability to upgrade your software version past a certain date. However, if you do keep your maintenance contract up to date, you will have the ability to upgrade. If we look here, there will be 3 different, I'll call them software editions or levels. So the standard level will support debug features on all devices, and this will address a majority of our customer common use cases. In the next slide, we'll get into a little more detail as to what's included in the standard level. On the Pro type level, this will include all of the features, all of the debug features here in the standard level, but it will also include your real-time analysis, your secure core debug, and your image UCB checkers, which is some extra security that's added there to keep the device safe from inadvertently programming incorrect binary images and creating bricks. The third level or edition is test. And all the features, and this will contain all the features of the Pro. So you'll have all your standard debug and all of your standard real-time analysis and trace features, but you will not have the GUI or the integrated development environment. And the reason for this is that the test edition is intended to operate in a continuous integration type environment where a Jenkins type Docker, for example, will be able to call the debugger from the command line, and then you will not need an IDE. And this will also be a very cost-effective solution. So if we look at the different models here, let's focus here on the standard edition. So you can see here that we'll have our, WinIDEA IDE support. You'll have support for the tasking debuggers as well as the Infineon Mini Wiggler and others. You will be able to do program download on your target. You will have multi-core support. You'll see the plethora of low-level and high-level debug features, including, setting software and hardware breakpoints, doing OS-aware views, source level debugging, call stack views, watch views, memory views, etc. All the things that we're used to when using a debugger. You'll see here that the real-time analysis here in the trace is really not included. Again, remember, if you remember on the previous slide, I said in devices like emulation devices like the TC4X, where there's a 2 meg block of EMEM that's given to you, you'll be able to use that. But in terms of having like a large available memory block for doing trace, that's not available on the standard blue box. If we look at the professional edition, you'll see that all the features here are supported. All the WinIDEA features here are supported. So this would be the method that we would recommend for you to work at, as it gives you, all of the trace debug features, as well as multi-SoC sync. And then if we look here at the test, you'll see that all of the features here are supported, except for the IDE, as previously mentioned. So let's transition now into SmartCode, the TC4X IDE. And so if we look at the feature set or what's available, so the tool chain, as mentioned, will support all of the architectures and microprocessor cores integrated in the TC4X. One of the areas where there's been a lot of functionality added has been for hardware debugger support. So you can see here that the SmartCode Eclipse IDE will allow connection to target hardware via the tasking blue box or the Infineon Mini Wiggler. When we're talking about the Infineon Mini Wiggler, you will have the ability to debug the tri-core cores only. If you want to go ahead and debug the PPU, you will need to use the iC7mini, and you will currently have to use a standalone version of WinIDEA, and I will describe a little bit more about that in a little bit. And there's also an Eclipse plugin, which actually allows the Eclipse SmartCode application to work with WinIDEA, allowing you to access, the powerful and versatile WinIDEA IDE. SmartCode also now conforms to all of the industry-leading standards. MISRA-C, Cert-C is included. You'll also see Tri-Core EABI and Synopsys EABI compliance, as well as IEEE 754 floating point, and the ELF dwarf industry standards are complied with. So let's look at our compiler support. So if we look at there's a C++ compiler for the Tri-Core version 1.8 architecture. This compiler has C function qualifiers and a flexible interrupt service routine sequence for hypervisor. You can see also for the C++ compiler that there's a new front end which supports C++ 17, 14, 11, as well as partially supporting C++ 20. And there's also ISO C 2018 language support has been offered, or is added, sorry. If we look at the parallel processing unit, there's also a C and C++ compiler for the PPU. Part of the this functionality includes a vector DSP instruction set for your single instruction multiple data for doing your vector and matrix calculations. There's support for vector DSP instructions, auto vectorization, and auto bundling. You can see the C++ front end supports the same levels or revisions of C++, as well as the ISO C 2018 language standard. And you can also see here that, again, it conforms to the Synopsys EABI definition. And why that is important is that if you're using another if you have other object files, that are built with other compilers which conform to the Synopsys EABI, then you can cross-link these object files into the same project. So again, all TC4 cores are supported. Looking at some of the different architectures that have compiler support, there is a C++ compiler for the cybersecurity real-time module. If you're familiar with the ARIX family of microcontrollers, you'll know that in the TC3 that there was the hardware security module, and that was based on a ARM Cortex core. Infineon, when they moved to the 4th generation or the TC4X, they changed the HSM to the cybersecurity real-time module, and instead of being based on an ARM architecture, now it's a Tri-Core 1.8 architecture. And so that C++ tool set is available for that, and you can see that the same C++ front end and ISO-C language version are supported. There is a C compiler toolset for the generic timer module from Bosch. It is backwards compatible, so you can see here it is compliant to the latest version, which is version 4.x. And there's also a C compiler here for the 8-bit standby controller, which is based on a XC800 architecture. So as I mentioned earlier, one of the key things that have been added with SmartCode is hardware debugger support. So SmartCode comes pre-configured for efficient use of the iC7mini Blue Box in your TC4X development. And so the following add-on options can be purchased separately. So you can see that there's the Performance Basic and the Performance Debug. Both of these will come with an iC7mini Blue Box, and you can see the difference here is that the Performance Basic will have a standard edition of WinIDEA, and the Performance Debug will have, WinIDEA Pro. So when you look at, so what's actually included here with this iC7mini, and so you'll get the iC7mini Blue Box, you'll get the Mini C USB power supply, and you will get the Infineon DAP adapter, which will allow you to connect to the DAP or the DAP-E interface, on your board. We would like to point out again that the standard edition is a limited function set, so it's not recommended unless price is really a limiting factor. If price does force you into the standard option, please keep in mind that an upgrade, is available, for an additional cost later on down the road. And as previously mentioned, also the Pro Edition would be recommended for all your functions necessary for high performance debug. You can see the grayed out options down here for Performance Debug Trace and Performance Debug Trace Sync. And the reason that's grayed out yet is because the iC7 Pro and Max are not available yet. If we look at a high level of our tool set features, there's a lot of carryover from the 10.1 version. You can see here all of the compilers here are included. As I've already discussed, you can see here the PPU optimized library functions. The PPU runtime environment is in process and will be available in a future patch. What the runtime environment is it's basically a channel that sits between Tri-Core and PPU, and that's a way that they can communicate amongst themselves. So if the Tri-Core has a matrix calculation that it needs to do, it can kind of use the scheduler that's built into the RTE, send it over to the PPU. PPU can go ahead and do the necessary math and kind of forward the answer back. And this all happens autonomously. So the application developer doesn't have to do anything special in order to do this. The advanced multi-core support and flexible memory allocation, the linker script language, the support for cross-linking, having the integrated static analysis like MISRA and CertC, as well as availability in either a Linux or Windows OS, are all available with this version of SmartCode. If we look at some of the safety features here, you can see that it has been developed with Automotive SPICE Level 2 processes. It does come with a combined safety and security manual for the Tri-Core and the PPU. There are qualified runtime libraries per ISO 26262 up to ASIL D for both the runtime and the PPU. TÜV certification is expected probably mid-year. It's been applied for, but it takes the TÜV time in order to go through the process of certifying the tool set. And you can see here also that the additional qualification kit is no longer required. So when you buy your SmartCode license, the safety and security manual will come, in the documentation folder of where the tool set is installed. So let's take a couple looks here. Look at the at some screen captures from 10.2. So if you're familiar with the tasking software IDE, you'll see it's the same as all of our other products. So easy to use, very intuitive. There's no need to learn anything new. The workspace is set up the same, ability to look at your C-source. Outline views here are available as well as here the console where you can look at the verbose view where you can see all of the different pieces of the tool set and which options are used for each. So you can look at, what optimization settings that you've selected for your compiler, assembler, linker, locator, etc. This is new, so let's pay a little bit more attention here. And so this is, setting up the debug configuration, so how you're going to connect to your external hardware. And you can see there's a new tab here that's been added called Tasking WinIDEA. And so you'll have the ability here to select the device as well as the hardware that you're using. So you can see kind of over here in under Tasking WinIDEA, I've created a configuration here for the iC7mini, for the RX Mini Wiggler, as well as for the iC7mini. You'll see here, and with this configure button here, you'll be able to go in and configure your WinIDEA workspace. So it's again very flexible. If you already have a pre-saved WinIDEA workspace, you can load it here. Automatically. You'll also notice here that there's a tasking WinIDEA and a tasking debugger. That's because a lot of our users really like the tri-core T-Sim or simulator. The simulator is not available within WinIDEA as of today. It will be integrated further down the road in future releases of the product. But so right now, you have the option also to set up, a separate simulator if you don't want to connect to the hardware and just kind of work with the simulator. Now, when we go ahead and hit debug and do the program download to our target, the debug perspective here that's going to start is the legacy, say, view of the tasking embedded debugger, but you will notice here the little WinIDEA icon up here. And so this does communicate through the plugin that I talked about. So it is working with WinIDEA. What we wanted to do, though, is kind of save that view for those that are familiar with the tasking debug perspective. And so you'll see you can look at variables. You still have your breakpoints, all of your registers, your disassemble view, your memory watch area here, your C-source, your console, and your debug console here where you can specify different cores, stop and start different cores, etc. One point that I do want to point out here is we do provide you a lot of flexibility here. And so you can see there's this box here which you can enable or disable. So this allows you to launch a separate standalone instance of WinIDEA. And so you can see here that we've checked that option here. So what's going to happen again is that when you hit debug, you're going to, not only are you going to see this view, but you're also going to see a separate WinIDEA view. And WinIDEA has a lot more flexibility and than the traditional or legacy tasking view. So you can then kind of run them both kind of concurrently. So if I want to sit here, if I want to do a reset here, and if I really want to work out a WinIDEA, what you're going to see here, you'll see the reset, in this perspective as well. And so the two perspectives can kind of hand off back and forth and work with one another. So it's really what you're used to and what you're comfortable with. So if you really like, and I guess I should also take a little step back here because things like trace and some of the advanced analysis options that WinIDEA offer that the legacy tasking debugger didn't do, you're going to need to operate inside of WinIDEA, obviously, for those functions. So if we look at the licensing model, SmartCode is offered as a time-based license, currently in either a 6-month or 1-year term. Support and maintenance is included in the license fee, and we offer either a node-locked or a floating-based license. You'll also see here a 30-day evaluation license for free, so which is offered as a node-locked license. So if you want to play around with SmartCode a little bit and see the capability prior to purchasing, you have that option. So let's look at some of the key takeaways from what we've learned today. So the iC7mini does provide an improved debug performance. It does come in a compact form factor with lower power consumption and noise. If you're familiar with the iC5700, it's easily a third of the size and a third of the weight. So it is very, it has a very nice form factor. And again, it's set up to kind of operate in that rack type system. And it does also bring along with it some Ethernet capability. So it's really easy to hook it up in that type of environment. Basically, I was a little ahead of myself here. So the iC7mini is designed for remote operation and can be located anywhere globally, separate from your software developers, if that's the system, or that's how you want to implement your development environment. So SmartCode does provide toolset support. And when I say toolset support, that means a compiler, assembler, linker, locator are all included. And so this toolset support is for all architectures and all microprocessor cores integrated in the TC4X. SmartCode Eclipse IDE does allow connection to the target hardware via the tasking blue box, and the tasking and the Eclipse plugin allows access to WinIDEA. And finally, SmartCode has added ISO C 2018 language support, and the new C++ front end does support the latest and greatest in terms of C++ additions that are available. So if you're interested in any additional information, please see the following contact information. And with that, we will move on to our Q&A session. So we have a couple questions here. Let me see. Will there be different licensing models to compile software for tri-core cores and CRSM? Okay, so the standard compiler is going to be the same because it's based on tri-core 1.8. There are some extensions, however, that are added for the CRSM to address some of the security type requirements that are needed. Is the compiler compatible for Lauterbach? So the compiler. So when the compiler can be set up to generate either an ELF or hex or an SRecord type output format. So if you have a Lauterbach debugger, for example, yes, you can take the output source that's generated and you can you can download and use your third-party debugger. What about SCR, same license to compile SCR? Yes. So the all of that's one of the things when I was talking about heterogeneous tool sets is that SmartCode will come with the ability to do GTM code, SCR code, tri-core core code, etc. So yes, it comes included in the bundle. Okay, here's a couple other questions. What are the main advantages of using the tasking iC7mini Blue Box over the Infineon Mini Wiggler? Ooh, good question. In our opinion, the Mini Wiggler is really good for evaluation purposes, for working on an evaluation board, for doing things like single stepping or setting breakpoints or doing things on a single core. But when you get into some of these multi-core and you're trying to do trace, the Mini Wiggler isn't optimized for those type of scenarios. And so in those type cases, an industry proven tool like the iC7mini with higher bandwidth may be better. I think if we expound a little bit on that, the Mini Wiggler, it works over USB, but it doesn't have the Ethernet capability. If you look at things like debug performance, you're pretty much maxed out with the Mini Wiggler at about 20 megahertz, whereas the iC7mini can get you up to around 120 megahertz. And then the Infineon Mini Wiggler is again limited to Infineon tri-core architectures, where if you're using a different architecture, you're going to need something else, and that's where the tasking iC7mini comes in there. And then things like autonomous data acquisition and time critical SoC management, things like that, are things that are all available and supported on the iC7mini that aren't supported with the Infineon Mini Wiggler. So that was a really good question. So thank you for who asked that. What is the plan for SmartCode safety certification, and is the compiler already qualified? So I think I addressed this in the material, but the SmartCode product, it comes already with the safety and security manual. So it already gives you how we conform or comply to the standards, what tests that we've used, what test suites, that, are we using Perennial, or are we using some other off-the-shelf tool set for evaluating and showing that our tool set complies to the standard. It does allow you to develop from ASIL B to ASIL D. The TÜV certification, will be done by an independent company and is planned for, again, mid-2024. We should have a better feel for that probably in the April timeframe. So if you want to reach out to us for a more specific date, please do that. So I think that addresses that question. Okay, I got one last question here, and it's another really good question. So the question is, will the existing iC5000 series continue to be supported in WinIDEA? And so the answer is yes for the foreseeable future. We do have enough components to build some iC5000s, but as I mentioned, it is a mature solution, and so there's natural end of lifing of components going on. And so in order to effectively support that version of the debugger isn't optimal. And so newer devices for existing CPU families that are provided will still be supported on the iC5000, iC5700, and iC7. Newer CPU families that require like substantial changes, like RISC-V, for example, that's only going to be provided on the iC5700 and the iC7. And then advanced like autonomous functions like blue box operation, without WinIDEA, those are going to only be added to the iC7 only. And then kind of to take that question, say, a little bit further, so the iC7 is going to support all actively used devices. Of course, there's some legacy architectures like the S12 and the RL78, which were not ported. And that's where, as I mentioned, we have kind of some extra, iC5000s there that, even though that we're not actively marketing those iC5000 solutions, since now we have the iC7. If you do need it for some of these legacy architectures, we will still be able to support that. However, we do recommend and encourage our customers to look at the iC7 family of debuggers. So that was my last question there. So this concludes our product release webinar for the iC7 Blue Box hardware debugger and the SmartCode toolset for TC4X. I'd like to thank you for your participation, and I wish you all a wonderful, happy holidays.